This is an introduction to the CodaOctopus construction monitoring solution, or otherwise referred to as CMS. The revolutionary construction monitoring solution is a comprehensive construction management system designed for concrete armored block placement, enabling users to see blocks in real time, track each block during placement, place, mark the as laid position, record all block placement and as laid data, quality check the panel and individual blocks for quality compliance, document the entire placement workflow by date and time, Our CMS solution has been developed in collaboration with underwater construction firms since 2008 and has been approved by the block manufacturers who designed the Breakwater technical specifications. Using the Echoscope technology, users can now place anywhere between 76 to 200 blocks per day, depending on the size of the block. For a comprehensive visualization and mapping solution, it is recommended to utilize the full equipment composition. This includes CodaOctopus construction monitoring solution software, an Echoscope pipe, the world's only 5-dimensional and 6-dimensional real-time imaging sonar, mounted with an ISAR or integrated single-axis rotator, for real-time flexibility of pitch angle on a CMS frame. A 3D Connect 5G with laptop, the intuitive integration platform to streamline your CodaOctopus solution. A F180R series inertial navigation system, used for wire cranes only in conjunction with a specialized GPS antenna frame. While not a part of the solution itself, for pre- and post-lay survey, you can pair the CMS solution with an Echoscope LiDAR camera designed for real-time 3D imaging applications above the waterline. And lastly, CodaOctopus use Pipe Core software for both pre- and post-lay surveys. Whether you need a dual or triple frequency Echoscope pipe depends on the size of the blocks being placed, as well as the field of view requirements. The Echoscope pipe supplied for our Breakwater solution includes a built-in wet switch that automatically turns off the sonar when it is removed from the water. Our CMS solution is very adaptable and mobile and can be deployed on excavators. This is one of the most common methods of deployment for the CMS solution. The Echoscope is mounted on a horizontal frame on the placement tool. For accurate block placement, the excavator must have a 3D machine control system installed to provide accurate pin position to the CMS system. And wire cranes. The Echoscope is mounted on the bottom of the frame suspended by the wire crane in a similar position as the excavator deployment. For accurate block placement and panel mapping, a tall mast, typically 8 meters, is attached with rigid support bars to mount the F180R INS spreader bar system with waterproof antenna. The spreader bar remains out of the water at all times during placement. The mounting arrangement would be designed by the customer. CodaOctopus will provide assistance through the process to ensure that the arrangement is suitable to obtain the clearest image of the blocks being placed. An example of the CMS solution equipment spread. The Echoscope mounted to an ISAR is then mounted to the frame. The F185R assembly is mounted to the top of the mast. This is for wire cranes only. Inside the cabin, the 3D Connect 5G is set up alongside the laptop. The acoustic point cloud data of each block is recognized by the CodaOctopus CMS software. The prelay data provided to the CMS software describes the panel, position, unique reference, block type, and size which CMS uses to accurately lock the 3D model onto the point cloud data. The operator has a clear 3D model of the block to work from, enabling increased accuracy of block lay, as the operator can see all sides of the block. Block detection can as easily be performed on hanging movement blocks during placement as well as laid blocks on the breakwater slope. The block tracker outputs the position and attitude of the block for accurate digital twin modeling. The operator can have real-time 3D visualization of live block data and the slope regardless of the water conditions, both day and night capability, increasing productivity of these operations. The unique model tracking technology means the final position and attitude can be recorded in the global CMS database. The tracking can be further activated on subsequent survey data, allowing the master asset database to be quickly updated with any block placement movement. Critically, when block tracing is employed at all events, placement, settlement, and final slope survey, a complete history of each block's movement is captured and available for analysis for slope stability. Alignment of the CMS operator's activities with the broader project management team by broadcasting real-time critical data to the construction team as a whole, thus making the interaction with the crane operators on the breakwater construction site, often miles away from the project control location, much more efficient and effective. CMS Enterprise Management System is an additional module for the CMS software. CMS can connect to one or more live cranes, broadcasting key data from the placement crane to the project management team. Live update in CMS Monitor allow the GIS, charting display, and the 3D breakwater as built model to be updated, allowing users to view up-to-date progress information. Extend capability from diver to mark block as laid by the construction team, and centralizing the storage of project data outside of the crane operator's console. CMS reporting tool uses our physics engine. It calculates the contact point of each block, and from it estimates whether the placement is a good or bad placement. Using our pose estimation method, which assesses the contact points of the as-laid blocks, our reporting tool is intended to aid users to identify poorly laid blocks within the breakwater construction. It integrates with our CMS software and as-laid files with the block data. This is then displayed in a grid view and allows the user to filter and interact with the data to refine the blocks they would like to examine. CMS is currently being used on many breakwater projects across the world, many often multi-year projects. Incorporating both pre- and post-lay survey activities for all common single-layer concrete armor block types. Supported block types include CMS generates industry-standard deliverables for breakwaters and extends to the full-scope breakwater construction from pre-lay survey, placement, monitoring, QC, post-lay survey, and remediation. In addition, the Echoscope can be paired with our Echoscope Air LiDAR 3D depth camera to provide above and below the water line imaging seamlessly. Unlike traditional breakwater construction methods, which often require various approaches for placement, CMS solution streamlines both slope and placement surveys. Our CMS platform allows the entirety of workflow steps to be conducted on demand using exactly the same equipment, without survey vessels or additional sensors. Because the solution provides a seamless and dynamic workflow and allows the operator to see the blocks in real-time 3D, this significantly reduces the time it takes to place the blocks and increases the safety of those involved in the block placement process. Users also obtain significant productivity gains when using our CMS solution in the construction or remediation of breakwater sites. Our CMS Breakwater solution has been adopted by major operators and is proven to deliver significant productivity gains, some examples of which are Constanta, Romania. Situated along the western coastline of the Black Sea, the port of Constanta spans more than 9,700 acres, shielded by two distinct breakwaters positioned to the north and south. The northern breakwater stretches 8,344 meters in length, while the southern breakwater extends 5,560 meters. Together, these strictures safeguard the port, ranking as the largest on the Black Sea and the 17th largest in Europe. Colombo, Sri Lanka. After 4 years of construction, the port of Colombo was completed in 2012, emerging as the largest and most bustling port in Sri Lanka. Situated in Colombo, the nation's commercial hub, it mirrors the setup of the Constanta port with two distinct breakwaters. The primary breakwater spans 5,140 meters in length, while the secondary breakwater, measuring 1,600 meters, encircles a smaller harbor. Upper Zakkum oil field, Abu Dhabi. Constructed as artificial islands off the coast of Abu Dhabi, the breakwater of the Upper Zakkum oil field comprises over 49,000 blocks, meticulously positioned with the assistance of the Echoscope, each spanning 650 meters by 450 meters. These islands serve as a crucial defense for safeguarding the world's second-largest offshore oil field. We are proud that we have been able to deliver this solution to breakwater developers and significantly increase the number of blocks placed, anywhere between 76 to 200 blocks per day, while at the same time increasing safety. Van Ord Port Construction Project. Placement of 24,000 core lock armor units. Priceless cost savings. Over a duration of 1 to 2 years. Van Ord has been using the Echoscope real-time 3D imaging sonar on various projects from 2008 onwards where single-layer artificial armor units, Acropode and Acropode 2, need to be placed. During placement, the Echoscope 3D imaging sonar provides real-time guidance to the crane operator. The Echoscope has contributed to an increased productivity whilst improving safety. Eric Peters, Van Ord. CodaOctopus Construction Monitoring Solution. A patented and complete breakwater construction management system to see, track, place, record, validate, and document concrete armored block placement. For more information, you can reach us by email at sales@CodaOctopus.com or call our worldwide sales number +44 1315531380 or +14073524000 in the Americas.